Let's talk about curves. Because most curves you're seeing on furniture, they're pretty ugly. And that's probably because you guys are using a roundover bit like this. And if you look at some really good industrial design, like the corners of your iPhone, those curves are very carefully designed. And this has to do with the continuity of the curves and how they're connected from one surface to another. And in design, I wanted to pay a lot of attention to that in this particular project I was doing. And all the curves in this project have G2 or G3 continuity for a really smooth look. But I'm going to be honest with you, it's really hard to generate this unless you have something like a CNC machine. And even if you do have a CNC machine, you have to really pay attention to the curve analysis to get it to look just right. And I wanted the whole side of my piece to be carved out with this curve, which meant I'd have to start with some really thick 8/4 stock and glue some pieces together. And you did just see my miter saw kicking back due to the piece not being flat and pinching the blade. And my plan was to minimize the glue lines by gluing up two 10-inch wide pieces to a total length of about 20 inches. Now, these boards were really wide, and I pushed the aesthetics of eliminating the glue line over actual wood movement. Normally, you would alternate the grain orientation like this to minimize movement. Now, I didn't do that in one of my first pieces, and I'll get to why that caused some problems in a bit. But for now, my first thing to do was to drop it down the CNC machine and flatten the bottom. I used my 3D printed side clamps to hold the workpiece down so I could surface the entire top. And if you want to print some of these yourself, I'll post a link in the description on where you can get the STL file. I only flattened the bottom side because the top would be carved out in a little bit. Now my curve was so large that my piece would have had to have been 3 inches thick, or nearly 3 inches thick, to do the entire curve that I wanted. Instead, I decided to cheat a little bit, and I cross-cut it in half, and then I could go ahead and add an angle and kink the piece a bit and re-glue it together. Now, because I surfaced only the bottom of it, I had to use the left side of the saw blade to make my angle cut. And generally you don't want to do this, particularly with a left tilting saw blade, because it could cause some pinching. But it was only 5.5 degrees, and I figured it'd be safe, and I used a featherboard to help keep everything tight, and it seemed pretty good and safe when I did it this way. Now I had to figure out a way to glue together the ingrained pieces. I'll admit, I was kind of a domino hater, but now I absolutely love this tool. It is just so easy to generate pretty rock-solid joinery that is completely hidden. I'm still trying to figure out the best way to glue up the dominoes, and I don't know, I just kind of put glue on everything and squeeze all the extra out. And if you're looking carefully, I did use an angled piece that I'd cut at that same 5.5 degrees to prop up the end when I was gluing everything together. While the glue was drying, I decided to work on the face frames. I used some double-sided tape to hold my pieces down because there wasn't quite enough room for tabs on the minimal size I was cutting out. I did toss in a few of my 3D printed toe clamps just in the locations where I knew nothing would hit, but even then I did crush one time. In wood, I found that a conventional cut will produce the best results, and in fusion this is called a right sideways compensation for the cut. But you'll still get chip out when it exits the side. And so what I do is I will do a left cut on just the entry point and then go about and do the final cut all the way through, and this helps prevent some chip out. Another trick to get some of the best finish on a cut like this is to leave about 20 thousandths of an inch and slowly go around and do it at the end. And for some reason I didn't do that, and I got a pretty rough cut on the first ones that I made. In subsequent ones, I'll fix that toolpath. It was then back to the trusty domino to attach the face frames together. I glued up the face frames doing one side at a time, and even though I was only doing one side, I loosely attached the other one with some dominoes just so that I could clamp it together really tightly, and then after the glue dried, I could take the clamps off, pull it back apart on the other side, and glue it together. And then it was back to cutting out the sides on the CNC machine. I used my same side clamps for mounting everything down, and used the little wedge piece that I'd used earlier for gluing the pieces together under the front to support everything. The bottom of the feet had to be cut off precisely vertical at this point, and I used an upcut bit to do this operation. I feel like a lot of people use Vectric V-Carve for carving out stuff, and that's really unfortunate because Autodesk Fusion has so many better toolpath options, like 3D Adaptive for roughing, which allows you to do a lot of really deep cuts and then come back and do smaller cuts, removing a lot of waste really quickly. I then machined the top piece in pretty much the same way, except I started with a surfacing bit to get the top perfectly flat, and then I machined the sides. I almost forgot to remove my dogs, and you'll see me remove them at the start there, which is pretty good because if I didn't, the bit would have for sure hit them. Now if you look at my back piece, you'll notice there's a slight angle at the bottom because I cut the sides and angled them out. And so the best way to cut that would be on the CNC. I decided to use some cherry plywood, MDF core cherry plywood, and this is really because of wood movement. I couldn't use solid wood in the back without having issues, and so some plywood or MDF core plywood would have been the best solution. And I did use tabs to hold them down, so I had to clean the tabs up on a flush trim router bit. I didn't want any MDF to be exposed, so I did cut a bottom piece out of solid cherry that would cover up the MDF bottom. I didn't have enough clearance and I did hit my clamps, again not too big of a deal, and I did do the same trick of first doing an entry on the exit just part way to make sure I could get a clean finish, which worked great. And you already know that I love the domino, so I used that to attach the two pieces together. But one of the tricks that I picked up along the way is you have to do a dry fit, and it's really good to use something other than real dominoes. So I 3D printed some just fake dominoes, and they're black, and I use those to do my test fits. That way I don't wreck any of my real dominoes. Next I need to attach the sides to the back, and I could just put them upside down on my table because the top was kind of my reference space at this point, and just mark some pencil lines on where I was going to add some dominoes. Then the domino mortises were routed out pretty quickly, and again, man, I really love this tool. It is so fast and easy to use. One of the problems of not alternating the wood grain meant that when I machined away a lot of the top, the wood would actually bow a bit because the moisture content would be different on the top than the outside. So because these sides were slightly bowed, I could pull that bow out by permanently mounting the shelves. And I made the shelves out of 3/4 inch solid cherry, just a couple pieces that I glued together and flattened. And like before, I decided to just use dominoes to attach them. At this point, it should be no surprise that I was going to attach the top with dominoes, and I rough assembled everything together with clamps really tight, marked where the dominoes on the top needed to be, and then I cut them out. I could disassemble my test fittings and then go ahead and sand the interior parts, which would be difficult to access after I glue it up. I decided to make everything a little bit more manageable by doing the glue up in stages. I put one of my side pieces down on my bench, and then I could add glue to all the mortise holes, put some tenons in it, and add some glue to the corresponding back piece and the shelves, and then assemble the two shelves and the back piece into the side. I attached the opposite side and stood it up just so I could clamp it. The other side didn't have any glue on yet, and then I spent a bunch of time carefully wiping all the squeeze out away. I let that dry for about 3 hours, and then I could remove the clamps and pound out the other side, which wasn't actually glued in yet. I could then add the glue to the other side and add all the domino tenons into it, and then glue that together and stand it up and attach a few clamps to hold it all nice and tight. Then it was a repeat of the whole process to attach the top, and this time I decided to use some blue tape to try and get the squeeze out, the excess glue to not go on my wood. And I think it helped a little bit, so I might be using the blue tape technique for my subsequent ones that I'm making. And at this point, you can guess how I'm going to attach the face frame on. And the only thing that's really interesting to talk about here is that side, which is my reference, is actually curved. And even though it's curved, the dominoes tend to line up pretty well, and it isn't a big issue to do this type of domino attachment with that curved reference. And at this point, you might notice I'm wearing a different dust mask. I hate dust masks, but you have to wear them. And I was previously using the RZ brand mask, which has a single strap, and it would never seal really well. When my head looked down, I'd feel a gap and breathe in air. And I switched to the Basecamp brand mask, which has a top strap, and it actually seals better. So if you're looking for a mask, maybe give this one a try. I'll put a link in the description. All right, the CNC router has had a lot of fun. Time for some hand routing. And this is just a chamfer bit. I want to put a little bit of a chamfer on the inside of my face frame and the outside of where the face frame attaches to. Also on the entirety of the project, just to kind of give it a nice sharp angle on everything. Before I glued the face frame on, I did put some blue tape to try and prevent some squeeze out from getting on places I didn't want to be. And I also used a brush to just brush on the glue, and that way it would kind of help eliminate the excess amount of glue getting everywhere. And this worked pretty well, but I did have to scrape off some of the glue on those chamfers that I just put on. Before finishing, I sanded everything up to 320. I feel like the finish is a little bit better when you go to 320, even though a lot of the manufacturers say just go to 220. I feel like 320 is just a little bit better. For the finish, I decided to use Osmo Poly-X in satin, and it's super easy to put on. You just use one of those white scuffy pads, whatever you call them, to wipe on some of it. And you put it on really light, wipe off any excess after you put it on, and really that's it. You let it dry overnight, 12 hours, add a second coat, and you're done. It does take a few weeks to fully cure to help scratches not happen as easily, but you can start using it within 24 hours. Without further ado, let's take a look at the finished piece. And here I'll point out that grain matching from where I cut it and added that angle. The sides match really well, really hard to tell. You can definitely tell the cross cut, but it's still pretty subtle, especially when you look at it from a distance. As usual, thanks for watching. Bye everyone.